Today, we are going to make Jupiter and Saturn binary with each other, along with a bunch of other things that you guys gave me in suggestions in the comments. So if you want to leave a suggestion, just put it down in the comments of this video or any of my videos, and let's get right into it. So here is Jupiter, and we are going to make Jupiter and Saturn binary with each other, but hopefully they don't collide with each other. So I think if I just move Saturn, here's Saturn right here, this little thing here, and if I just move it over next to Jupiter. Okay, so they're right next to each other. You can see here is Saturn and here's Jupiter. How close can I get them? We're gonna start decently far so they don't immediately destroy each other. Oh, okay. They are binary, even though it's very, very sketchy because of how close Saturn gets. So here's Saturn, and you can see how close it gets to Jupiter right there. I'm surprised the tidal forces don't rip it apart. That's kind of insane. Like right there. Oh my gosh. Okay, let's wait for it to get really close like this, because that doesn't rip it apart. I'm actually surprised. So now we're going to make that the new auto orbit and see if it can still survive. So there's Saturn going really, really close to Jupiter. Look how close it's getting. That's insane that it's not getting destroyed yet. Because if the moon was that close to Earth, the moon would get destroyed. So let's get it a little closer. Okay, that's got to do something. Look at that. Okay, we'll see right now what's going to happen. This is kind of like a collision with Saturn and Jupiter. Oh my gosh. Okay, they're so close, but they still, nothing's happening, which is very, very surprising. Okay, this is definitely going to destroy Saturn. Yeah, there it goes. It's starting to collide, and it gets absorbed into Jupiter. I'm sure Jupiter will just recover like normal because Jupiter is so massive. And there it is. Now we have no Saturn. Oh, and it put Jupiter on a course to go out of the solar system. So Jupiter got shot out of the solar system, never to be seen again just from that collision. That's crazy. Okay, you guys seem to like binary systems because this suggestion says make a Mercury and Moon binary system and make it orbit the Earth and see if it holds on. Okay, so we're gonna do kind of a close orbit on Mercury, and then we will have the moon binary with that like this. So it shows that the moon's orbiting Mercury, but they're actually orbiting each other, and you'll be able to see that if we turn on trails. See, they're kind of orbiting. Oh no, they're crashing into each other. Okay, that looks more stable after the collision. It's really hard to like see it, but yes, they are No, it got destroyed. Okay, I'll do one more try. Okay, Mercury and then the moon. Maybe kind of further. Okay, we'll try that and see what happens. So we're watching Mercury and the moon. It's so hard because they're both orbiting around the Earth, so it's hard to get. Yeah, look, there goes the moon. Oh, it's either too close that it hits or too far that it gets destroyed. But that was a good suggestion. All right, now we are going to look at the sun instead of the planets, and we are going to replace the sun with Proxima Centauri and make its luminosity exactly the same as the sun. Okay, so Proxima Centauri is a star that is a lot smaller than our sun. This is Proxima Centauri in comparison to the size of our sun. But we are going to make the luminosity, which is the energy output of the star, we're going to make that the same as the sun was. So even though it's smaller, it's outputting the same amount of energy, but the gravity is going to be less. So I think the planets will kind of fly away. So it's outputting a lot more energy than it's supposed to. So let's see what happens now. I don't think that really any of the planets are going to stay in orbit. Yeah, Mercury flies out, Venus flies out, Earth, they all do. Maybe some of these outer ones will have enough gravity. No. Okay. Look at all of that. All of the planets just fly away because Proxima Centauri isn't enough. So now I'm going to try doing more than one Proxima Centauri in the center to try to hold the planets. Okay. So I've now added 2 Proxima Centauris. I made them bigger than they usually are to kind of help with this. And each one is half as bright as the sun. So now we're going to see if 2 Proxima Centauris that are binary with each other can kind of be similar to having just one star. Okay, hopefully they don't crash into each other. Oh no, okay, well they're kind of moving, which is probably not great for the solar system, but let's see what happens. They're not crashing into each other, which is good. I mean, ideally they wouldn't be moving, so let's see. Is it gonna drag the planets with them? Oh, it launched Venus out. Okay, I think some of this stuff's gonna get pulled along. Yeah, look, Earth's getting pulled along with them. Same with Mars. Oh yeah, maybe Earth survives this. Oh, don't. No, it's going to get slingshotted out. Oh, and then it leaves. Okay, let's just see. I think it's going too fast. Wait, Earth survived. Earth is in orbit. It's getting really hot because it's really close to the stars. but it looks like that is the only planet that's gonna survive. Maybe Mars survives? I don't really know. Okay, it looks like Earth and Mars are the only planets that are surviving. Let's see what happens to Mars here. Yeah, now Mars is in orbit too. Okay, so Earth and Mars survived. Everything else gets launched out. So Earth would be okay if we randomly switched with these planets or these stars for some reason. All right, our next suggestion says terraform the moon and make it the same size as Earth and make it binary. Okay, so we are going to basically terraform the moon and then make it just like Earth and have it orbiting the Earth in a binary relationship. So here is the moon. So the first step to terraforming it is going to be to add some water to it. Now, with an object this small, you have to add a tiny bit of hydrogen to get the water to stick. We'll add that, and then we'll add some water to kind of fill in these craters. That's already looking really good. And then we're going to throw an atmosphere on here. Okay, that looks a lot better. We'll add some clouds too. Yes. We can add vegetation, and that'll turn it'll turn everything green. Okay, so there is a terraformed moon. But we need to make it bigger. We're going to go over to the mass and just switch it to 1 Earth. So it is exactly the same mass as Earth. Then we're going to save this as terraformed moon. And then we're going to make it binary with the Earth. So we're going to grab the Earth and go binary with the Earth. How far? Probably like that far. Okay, and then let's play time and see how this works. Okay, so because we're focusing on the Earth, it looks like the moon is still orbiting. But if you focus on the moon, it'll look like the Earth is orbiting, which means they are binary with each other. It's working. So now we have a Earth and a moon binary with each other. The moon's actually bigger because the moon's less dense than the Earth. And what's our life likelihood? Only 8.83%. Okay, I think I can make this a little bit better by changing some of these, like the rotational period, make 1 day. Interesting. It's not getting super high. It's only at 14.9. I wonder if that lowered Earth. It did lower Earth's a little bit. It's at 97.7 now. Interesting. So life probably still wouldn't develop on this moon, but if this was real, we could travel to the moon, and it's got pretty good conditions for life, I would say. Okay, here we are with J1407b, which, if you don't know, is the planet with the biggest rings in the universe that we've ever discovered. So for our last suggestion, we are going to collide J1407b with the smallest star known. And the smallest star known is about the same size as Saturn. So I'm just going to get a random star and make it the size of Saturn. And we're going to launch it at J1407b, trying to go right through the rings. So here is the star I made. It's named Jupiter because I made it out of Jupiter compared to Saturn. So it's even smaller than Saturn. So we're going to throw this at J1407b and see what happens. So it's on its way right now, and we're going to speed up time. Oh, okay, here it goes. It's going way fast now. Flying through. Universe Sandbox can only simulate so many rings. So in real life, it would probably crash into tons of rings. Oh, did I miss? Is it just going to fly right past? No. Oh, it must be heating it up. Look how hot J1407b is. Okay, so right here, actually, we're just going to zero the velocity, and the gravity should just collide them. Oh, you can see now it's really affecting the rings, pulling in a lot of those. And let's see how this collision happens. If J1407b collided with the smallest star, let's see what would happen. Oh, the way it's pulling the particles is making the game lag so much. And here they go. Collide. Oh, okay. Oh, it turned J1407b into a star for a second, and then it like cooled off enough. I don't know if that's how realistic that is, but it seems like it's mostly okay. The rings in the center are kind of getting messed up. You can see those here. But that is a collision between the planet with the biggest rings and the smallest star. Thank you so much for watching. If you have more suggestions, make sure you put them down in the comments. Join my Discord if you haven't, and I'll see you in the next video.